Today we're calculating this interesting limit. So we have a1 to the power of x plus a2 to the power of x plus an to the power of x, all divided by n, and then taken to the power of 1 over x. And we're interested in the limit when x goes to 0. Those a1, a2, an are n positive numbers. Notice that if I have a function f of x, positive function f of x, or a value, positive value, that f of x equals to e to the power of log of f of x. In our case, this expression is going to be our f of x. It is a positive number because all the numbers a1 through an are positive. But now if you look what we're trying to find, we try to find a limit of f of x, and that limit equals to this limit, as we just discussed, and this limit is actually equals to this limit. So what we did here, we took a limit outside of the exponential function and put it inside of the argument. We can always do it for any function we want as long as that function is continuous, and this exponential function is continuous. So now what we need to figure out is how to calculate limit of log of f of x. Before we do that, let's calculate log of f of x. So we have a logarithm of some number to a certain power. And we know there's a formula for logarithms that says that if I have this power d here, we can pull this power outside of the logarithm. And that's what we do here. We took this 1 over x and pull it out of the logarithm. And now what we're saying, well, we want to find a limit of this expression. What we can do, we can rewrite this expression as this logarithm divided by x. And we're going to call the numerator here as a function g and denominator as a function h of x. And then normally when you look at the limit of the ratio of two functions, it's actually a ratio of the limits. Now notice that both g of x and h of x are continuous function when x equals to 0. And that means that the limits are equals to the value of the functions at point 0. But now we have a problem. The problem is that the value of a function of both of these functions at x equals to 0 is 0. And we got 0 divided by 0. And to solve this problem, we would like to use what is probably the most useful formula in all theory of limits. And that's called L'Hopital rule. L'Hopital rule works when you're looking for limit of the ratio of functions, and you find that normal approach like we did before gives you 0 divided by 0 or infinity divided by infinity. And it turned out in that case, limit of the ratio of the functions equals to the limit of the ratio of the derivative of these functions. So what we need to do now is to calculate derivative of g and derivative of h. H is equals to x, and that means that h prime is equal to 1. That's very simple. But when it comes to g, it's a little bit more complicated, and let's go into that in more details. So this is our g. Now notice that it's logarithm of the ratio of two values, and the ratio of two values, as we know, the property of the logarithm, equals to difference in logarithms, which means it's a logarithm of sum of exponential functions minus logarithm of n. And let's call the first term as p of x, and the second term is still going to be logarithm n. Now we're going to take a derivative of this function, and derivative of a difference is a difference of the derivatives. Derivative of g is derivative of p minus derivative of this log n. Log n does not depend on x, it's a constant, and derivative of a constant is 0. And what we find that derivative of g equals to derivative of p. And all we need to do now is to find the derivative of p. Notice this p is a composition of two functions. The function q is a logarithm, and function r of x is that sum of the exponential functions. And we know that derivative of a composition of two functions equals to derivative of q with respect to its own argument, z, times derivative of r with respect to its argument, x. So derivative of q is 1 over z, and since in our case z should be r of x, it equals to 1 over r of x. Now we need to calculate derivative of r of x. Notice r of x is a sum of exponential functions, and derivative of a sum of functions is the sum of the derivatives. So essentially we differentiate each of those exponential functions and add them up. And derivative of an exponential function, like a to the power of x, is a to the power of x times logarithm of a, natural logarithm of a. And this is what we see here. So in this case, g prime will be equal to this expression. In our case, we're interested in the limit of this function when x goes to 0. Notice that g prime is continuous function when x equals to 0. And therefore, the value of this limit is the value of the function itself at the point 0. Also notice that a to the power of 0 equals to 1. And therefore, what we have in numerator is just sum of the logarithms. And what we have in denominator is the sum of 1s. And there are n1. So that's why we're dividing by n. Next thing, notice that sum of logarithms is a logarithm of the product, is a property of the logarithm. And therefore, we're going to get this expression. So we are calculating limit of log of f of x. And this is what it is. And we use the L'Hopital rule to get this expression for this limit. Now, derivative of h is 1. So really this limit is simply limit of g prime when x goes to 0. And that limit we just calculated, and that limit equals to 1 over n times logarithm of the product of those a's. Before continuing, let's look at this formula again. This formula allows us to take a coefficient in front of logarithm and put it inside of the logarithm. So in our case, we have a factor of 1 over n. Let's do that. And we get logarithm of the product of the a's to the power of 1 over n. And that's what we have here. Now that was limit of log of f of x. What we're interested in is limit of f of x. And that limit equals to e to the power of the limit we just calculated. But now let's look at this formula. What we find here is e to the power of logarithm of something equals to that something. And in our case, we can apply that formula and we find that e to the power of logarithm of something should be equal to that something. And that means that this thing should be equal to product of a's to the power of 1 over n. And that's our final answer.